Happy Pi Day, everyone! And what better way to celebrate March 14 than to give you a little snapshot of Euler's wizardry? Since Euler discovered the number e and popularized the adorable symbol we use today for pi, it's no surprise that during a leisurely break he toyed around with an interesting question. Which is bigger, e to the pi or pi to the e? It's not so obvious since both of these numbers are pretty close to 3. So how did he do it? First logical step was to take the natural log of both expressions. Next, he moved the exponents in front of the natural log, since that's a valid trick for logs. Then he simply divided each expression by pi times e. The pi's cancel on the left, and the e's cancel on the right, so he got natural log of e over e versus natural log pi over pi. Now here comes the wizardry. Euler was an absolute fanatic when it came to functions. He knew that they were the gateway to all sorts of interesting results, so he immediately converted both expressions into a more general function, namely natural log x over x. So now what? Well, since he was trying to figure out which expression was bigger, maybe he could get a clue from this function by finding a relative maximum or minimum value, assuming it had one. And we all know taking the derivative is the key to finding maxima and minima, so Euler did just that. He of course used the quotient rule to get y prime equals x times the derivative of natural log x, which is 1 over x, minus natural log x times the derivative of x, which is 1, all over x squared. And this is just 1 minus natural log x over x squared. He then set y prime equal to 0, and easily found that x equals e. At this point, Euler was certain that this was a maximum since he could easily visualize the graph of natural log x over x. He knew the graph of this function approached 0 for large values of x since x grows faster than natural log x. He also knew that it went through 0 when x was 1, and then plummeted down towards negative infinity for values closer to 0. But Euler knew he could also prove that this was a maximum by taking the second derivative. So, starting now with y prime equals 1 minus natural log x over x squared, Euler once again applied the quotient rule and got the following result. I'll leave it to you as a bonus exercise to show that this is true. He then evaluated y double prime of e and got this expression, which simplifies to negative 1 over e cubed. And since this is less than 0, Euler knew the concavity of the function at e was downward, thus proving that e was the exact value that maximized the function. So natural log e over e must be greater than natural log pi over pi. And this, of course, means that e to the pi is greater than pi to the e, but only by a whisker. Happy Pi Day, everyone. And as always, thanks for watching, and see you soon.